Hi everyone, and welcome to this webinar brought to you by the Information Lab. Here at the Information Lab, we dedicate ourselves to helping people make sense of data using Tableau and Alteryx. You're here with Adi, bringing you this first episode in our Spatial Essentials series. In this selection of webinars, we focus primarily on the application of spatial analytics and location intelligence for local government and public health. You'll probably notice a little overlap in this series and our location intelligence in Tableau series. Here, though, we'll also be working in Alteryx. The examples we use are going to be skewed towards public health application, but even if that isn't your industry, do stay tuned because the fundamental principles are absolutely transferable to any organization looking to add value through their geographic data. And those fundamental principles being where things are, establishing how many things are in those locations and dealing with spatial aggregation, and also figuring out what is close to what, dealing with proximity analysis. Now, the technical specs for adding value, I'm on Tableau 2020.1 and Alteryx version 2019.4. If you look in the description box of this video, you'll also see a link to a file share location where you can find all the data and starter workbooks that I'm using here. That's a zip file, so remember to hit right click and extract, perhaps to your desktop, before you start using it. It's going to be great practice to follow along with me, so do join in. Now, before we get going in earnest, a little bit more about me first. Prior to joining the Information Lab's Data School program, I worked in environmental epidemiology and exposure science, where I was assessing population level exposure to air and noise pollution, largely for cancer research and chronic respiratory studies. Now, the left-hand image on the slide is an example of what I'd typically be aiming to get to. That's the output of geostatistical modelling across Europe that we subsequently drop patient postcodes or home locations into in order to assign an exposure level. The right-hand side image is a combination of my past life and my current work. It's an emission surface of London based solely on modelled emissions of oxides of nitrogen, or NOx, at 20-metre grid intervals. And you can see quite clearly here that the major sources of NOx are in the transport network. And I've generated this emission surface in Alteryx, and before the end of this webinar series, I'll be taking you through the steps that will allow you to do the same. Now, what we're aiming to cover in this Spatial Essentials course are these core ideas that you're seeing on the screen just now. The fact that spatial data is special, it has some different characteristics to non-spatial data, but once we get to grips with the nature of those characteristics, we can start to answer a whole host of important questions. And throughout this series, we'll also look at incorporating core spatial principles that will help you to avoid the common pitfalls and also allow you to deliver accurate and meaningful insight to your users. Now, depending on the nature of your organization, you may find yourself doing some code switching, moving between the terms spatial analytics and location intelligence. But again, the fundamental motivation is the same. We're providing analytic and operational solutions across the organization that you work in, grabbing the spatial data to deliver insight, whether that's customers or clients or local residents or GP patients. And fundamentally, to generate location-based insights, we need to begin with the same core questions as any other business intelligence scenario. And that is simply, what opportunity or challenge is my organization trying to solve? Again, those questions fall into very broad, similar categories, addressing basic context, asking where are my stores, my schools, my GP surgeries, my salespeople, adding a little more sophistication, where's my nearest competitor, solving planning issues and site selection, what services exist within 5 kilometers of my proposed site or store, and thinking a bit more specifically for public health, what environmental factors are going to affect local residents. But an important caveat to this, If the question can't be or isn't answered by a map, then you can leave that out of your visualization. Your spatial processing might give you a single location, or a word, or a phrase answer, or a list, and that might be best represented visually in another way. So, from someone who absolutely loves a good map, think carefully before you include one. Now, with that important disclaimer out of the way, let's get into it. We begin with a quick foray into spatial data. For our purposes, there are two main types: spatially ready data and spatially enabled data. Our spatially ready data are typically coming in flat files or Excel sheets. We may have numerical fields for latitude and longitude, or we may have fields for which latitude and longitude can be derived, like addresses or place names or larger administrative units, states, counties, or countries, for example. In terms of the data, we don't have a spatial data type here, only numbers or strings, text fields. But those fields are ready to be enabled spatially. And we identify those spatially enabled data by the presence of a spatial geometry, a single column that's used to render the geometry of our spatial object on the screen. And that might be single points or lines, representing a road or river network, for example, or polygons, shapes that denote areas. And some of the file types you may see for this, and those that are read by Tableau: Esri shapefiles, still by far the most common file type; MapInfo tab files. MapInfo is another desktop-based GIS software. GeoJson, perhaps. GeoJson is typically seen in web mapping applications. GPX, which is GPS-based data, plotting routes and waypoints. If you use Strava, for example, this is what plots your route on the screen or on your device. And then KML or KMZ files. That's keyhole markup language. And this is the file type we can derive from Google Earth layers. Google Earth is free to download, so if you want to have a play with KML, you can absolutely get involved. And we will use examples of other file types as we go through this training. But since Esri shapefiles are the most common spatial file, still by quite a long way, it's important to flag the file structure up now and keep it in mind always when dealing with Esri shapefiles. The other spatial files that you may see are not so complex. Esri shapefiles themselves typically come zipped up. And when you extract the files, you'll get anywhere between 3 and 7 objects come out. Now, I've linked a blog on this in the description to this video that you can read at some stage if you're interested. But the key take-home message is you must keep the .shp extension, the .dbf, and the .shx files together. Don't delete any of them. Don't move one to another location without the others. If you extract your shapefile and find you have 7 component parts, just keep all of them together. But the core 3 are absolutely critical in drawing the shape and feeding in the attributes of that shape. What it is, what other characteristics are linked to it, for example. And in the image on the slide, you'll see I also have a .prj, something called a projection file. But if I want to move one, I'll move them all to the same place. That's absolutely key. Now, with all that in mind, let's take a look at some data in Tableau and figure out what's happening and how best to represent the spatial data that we've got. First off, how we connect the data to establish where our objects of interest are. Well, I'm going to open up Tableau now. And if you're following along at home, you want to open up the participant folder from your unzipped file share. And you want to go to Tableau Workbooks and open up the starter file. Now, in this first example, we have locations of traffic monitoring stations throughout London. This is a flat file. I'm going to right-click this traffic monitoring stations data source. I'll scroll down to properties, and you can see that's coming in as a .csv. You can also see in the data that we have fields called latitude and longitude. If I drift down to the data source pane in the bottom left, you can see that latitude and longitude are just decimal point numbers. There's nothing special about them at this point. But Tableau says, hey, you've got fields called latitude and longitude, so there's probably some geography about those two. And it gives them this globe icon in the same way that it wants to give a date, the calendar icon, or a string, the ABC. And when I put latitude and longitude in the view, what's actually happening is a scatter plot with a background image. So I'm going to go ahead and double click latitude, double click longitude to bring those into the view. And at the moment, I have one dot representing the average or the mean center geographic location for all the data in that traffic monitoring data set. And I can disaggregate or burst that single dot with a dimension to get the granularity that I want. I'm going to pick up the location ID, that's the unique ID for each of the monitoring stations, drop that onto detail, and I'll disaggregate the data to get the granularity that I want. And we've made our first map. Now we can also take a slightly different approach here in terms of getting objects onto the map. And that would be to convert latitude and longitude fields to dimensions. So let me clear this worksheet and drag latitude and longitude up to dimensions. And if you remember how Tableau behaves with this type of dimension, it isn't going to aggregate these fields when we push them into the view. So we'll automatically get a mark for each data point in our traffic monitoring stations data set. So let's go ahead and bring these into the view again. Here we go. So you've got two alternatives for just getting your objects onto a map and figuring out where things are. But what I'm also going to do here is add some base layer context to help my users understand what's going on. Traffic monitoring stations, logically, we know that they're going to sit by roads, so it makes sense to switch this layer on. And to get that detail in Tableau, we're going to move up to the Map menu in the top ribbon. I'm going to click Map, we'll roll down to Map Layers, and then we'll move across to the background style. Now here we have the light default Tableau layer. What I might do, switch on the streets. And that potentially isn't giving me enough detail, so I might go explicitly for the streets layer and switch that on instead. This is quite busy. Let me just change the color here. Maybe we'll go for this kind of burgundy. And I might sort of play around with the base layer, just figure out what's clear, what's not, and maybe wash this out a little. Okay, so we have a little bit more context. And we can zoom in by using this kind of play button, and then we go to the zoom option. We can zoom in to figure out what's going on in particular roads, what's related to what, how things sit in space. There we go, we can see my nice vector map rendering in the background. So that does give me some context on where these monitoring stations are in relation to other things. What we're going to do is zoom back out again to the full data set. We're going to do that using this pin icon. If we click this, that brings us out to the full extent of the data. Now also notice here that at the most granular level, we're looking at discrete objects, individual monitoring stations. So from a spatial perspective, this is point-based data. But Tableau will, by default, represent this as a circular dot. But for Tableau, that's just the choice of mark type. And we can alter that using the Shapes option and have geographic point data displayed using a variety of different shapes or symbols. So if I go into the marks card and hit this drop-down arrow, I'll move from automatic and I'll scroll down to shape. And you can see now that Tableau has rendered those points instead of closed up circles as sort of halos. If we click shape, We can make some adjustments based on perhaps what fits our purpose, and we can load in custom shapes in our palette here. I'm just going to stick with a fill dot because that's appropriate for the data. We're now going to take a look at another data set that will help to illustrate the other ways in which Tableau will put objects on a map. I've got school locations here in Tableau. Let's move into a new worksheet. So I have school locations in Tableau. You've seen here that I've arranged the fields into folders just to give me a bit more structure. And if I go through some of the important fields, I've got the address details of each of these schools in London, its postcode, its town, and then in the school details, some of these are kind of self-explanatory for gender, so whether it's single sex or mixed school. Status, if we right click and describe, we can see what's inside here. Okay, so status is addressing open and closed schools and those that might be closing soon. And then the type of school, we can also right click and hit describe. And we get that type of school from all of those that are classified in the UK. Now notice that we don't have fields called latitude and longitude in this example. We do have generated latitude and longitude fields, but these are being generated by Tableau on the basis of this postcode field. And we're going to come back to those generated latitude longitudes in our next episode. So I'm going to minimize the address details. Let's get postcode out of the way. And we'll just move back to the measures. Again, we don't have fields explicitly called latitude and longitude. So Tableau hasn't been able to intelligently allocate the globe symbol, and it won't automatically send in a base map when we try to plot the points that are contained in this data. But I know that it's the X and Y fields, that they're the ones that we want. X and Y are perhaps less useful to newcomers to spatial data, but X and Y are often used to donate longitude and latitude fields. And here's why. Lines of latitude run vertically, north and south from the equator, from 0 degrees at the equator to plus or minus 90 degrees at the poles. Lines of longitude run horizontally, east and west of the prime or Greenwich meridian, from 0 at that prime meridian to plus or minus 180 degrees at the international date line. Thinking of latitude as the y-axis and longitude as the x-axis helps us to orientate ourselves. Let's go back into Tableau and sort out our data. To avoid any confusion here, we're going to go ahead and rename the x and y straight away. So as I said, x is going to be our longitude. So we'll right click, go to rename, and we're going to call that longitude. On our y field, we're going to right click, rename, and our y is our latitude. Our values running north and south from the equator. Okay, perfect. Now still, Tableau hasn't understood what we want, so we haven't, just by renaming those fields, been assigned a globe for latitude and longitude. But that's fine, because we can tell Tableau that this is what we want. So all we're going to do is right-click latitude and move up in the options to geographic role and scroll down to the geographic role that we want. In this case, latitude for latitude. And then we'll do the same for longitude. Right-click, move up to geographic role, and then down to longitude. And you can see that that globe pops up. Now, in just a second, I'm going to create a map of those schools based on that latitude and longitude field. If you're following along at home, hit pause and give yourself a moment to do the same. Try to create something like this. Okay, I hope you all had a go. We're now going to build out that solution. Seen previously that we had converted our X, Y fields into longitude and latitude. We'd rename them, and then we'd assign them a geographic role to get the globe to pop up. So then it's simply double click for latitude, double click for longitude, and then we'll pick the object ID, which is the unique ID for each of the schools, to disaggregate that to the level of detail that we want. Now, in my example, I changed the color to burgundy. And in my example, I'd also changed my base map to have a look at the streets layer. And let's just double check what we took out. Yep, so we just washed that layer out a little bit, going to map layers, and then just sort of calming that down ever so slightly in the background. So that's one possible solution. Remember, the other solution, let me clear this off, would have been just to grab latitude and longitude, shift them up into the dimensions, remembering that Tableau won't aggregate these when we bring them into the view. And from the dimensions, double click and double click. And then do some aesthetic adjustments. So readjust the size to make those a little smaller. Change the color perhaps to this burgundy. And then we have that streets map layer in the background from the work I've just done. But again, to change those, we just drift up to the map option. In the menu bar, hit map layers, and then go ahead and change from light to streets. Okay, perfect. If you're still with me, well done. We're going to move into a slightly different scenario now, one in which we don't explicitly have latitude, longitude fields in our data. If we don't have those numerical data fields, we can do something else, and that is to get Tableau to generate latitude and longitude using its internal geocoding engine. So let's have a look at another data set. If you're following along with me at home, we're going to add new data, and we're looking for our cities data set, which is an Excel file. And then is in our data sources folder from the file share link. And again, that's a cities and Excel file. So we're going to open that up. And let's just go here into the canvas. Perfect. Now notice that the locations field has come in as a string, but I know that contains a list of cities. These are cities in the UK. So I can tell Tableau that the items in the locations field are cities. So it matches them with the list of cities that it has in its geocoding engine, its internal reference sheet that matches particular place names with their latitude and longitude values. So watch. I help Tableau understand what the geographic role is by right-clicking, moving down to geographic role, and selecting city, because that locations field has cities. Now keep your eyes to the left of this drop-down menu, because you're going to see generated latitude and longitude fields pop up into the measures. And there we go. These have been generated by Tableau's internal geocoding engine. Once we've established what that geographic role is, we're just going to double-click locations and bring that into the view. Now, what I'll do is just change these points. Let's call that red. Perhaps make it slightly smaller. I'm also going to add location onto label so you can see what's going on. All right. Now, in the bottom right, you can see that something's gone wrong in the data. We have one unknown value. So we're not going to leave that alone, because I think that this data set is complete and correct. So I'm going to left click on the unknown. I'm going to edit locations to correct the unknown. If we work from top to bottom, the country or region has been set up correctly. We're in the United Kingdom. We don't have a field that references a state or a province, so that's fine to read none. And the locations field references the cities. So that is set up correctly. But you can see that we've got a problem with Hull. And in this case, the problem is that Tableau has a range of cities that have Hull in the name. So if I start typing this in, you can see that we have a number of options and Tableau doesn't know which one to pick. So we have an ambiguous city name here. Now I know that when I was setting this up, it was Kingston upon Hull that I was interested in. So I'm going to go ahead and select Kingston upon Hull. And that now takes care of my issue. If I move that to the left, you're going to see when I OK this, Hull is going to pop up on the map. There we go. Over in the east of England. Perfect. Now, so far, we've been dealing with these spatially ready file formats. To add spatially enabled data, we follow the same procedure as by connecting to all data sources. We just select a different thing. I'm going to drift into this new worksheet where we're going to be looking at the addition of shapefiles. So I'm going to move up to this plus icon, add new data, and we're going to connect to a spatial file. In this case, I'm going to add in a shapefile for London boroughs. I'm going to open that and OK this. You can see that the extension there is the SHP. That's the file extension that draws the shape on the screen. Though do remember that we're going to keep them all together. So let's open that and take a look at the fields. Now, when we look at these fields, you'll see immediately that we already have a geometry. This is a natively spatial file, spatially enabled. We have that geometry. And we see the geometry type is polygon. So when I render this on the screen, I'm expecting to see shapes that represent an area. So let's go ahead and bring this in. I'm going to go into my worksheet. I'm going to double click on geometry. So there I have shapes denoting area. I'm going to clean up those boundaries a little, but not like that. Let's change the border rather than the internal color. Okay, we have each of those shapes representing a borough of London. If I drag name in from the dimensions to the detail, I'm able to see which borough is being represented. Perfect. Now I have another shapefile that I know to be roads. So what I'm going to do is add in, by connecting to data, another spatial file. I'm going to go and have a look for our roads. And this one, I'm just scrolling down. Again, looking for an SHP file. This is the link that I'm going to use. I'm going to open that up. Now this you can see has many more columns, so it's a much richer data set. But if we scroll all the way across the right-hand side, again, natively spatial. It's got a geometry column, and that geometry type is a line or a line string. And this is an appropriate way to represent roads on a map. So let's see how that looks in Tableau. I'll go back into a new worksheet for my roads. Same thing again. I'm going to double click the geometry to add this in. Okay, looks good. I've plotted this geometry and it renders as lines. Super stuff so far. Now you might be remembering at this stage that I mentioned the Esri shapefiles are common, but they're not the only type of spatially enabled files that we have access to in Tableau. And what I've done in advance is sketch out a quick area, a polygon in Google Earth, which is free to download. And I saved that shape as a KML file. So if I hit the connect data, I go to spatial file again, you'll find this KML file in your download from your content in the data sources. And it's this KML file here. Now, what you're going to do is hit pause at this stage, bring this KML file in, and see if you're able to create this view. So follow the steps that we've done before, bring the spatial file in, check the columns for detail, look at the geometry. We want to bring the geometry in. Remember what you need to do to get that geometry onto the map. Now, don't worry so much about getting an exact color match here. Just try your best to represent the data on the map. Okay, here is how we make it. I'm going to go from scratch. Got a solutions sheet ready. I'm going to add my new data source. So I went to spatial file. It's in my data sources as Greenwich and Blackheath. It's a KML file. So I open that up. And when you open it up, you see that's a very small file. It's a single polygon representing Greenwich and Blackheath. When you're exporting from Google Earth, you can add a description, but I haven't done that. Now, in order to build the map, as before, I move into the measures, double click my geometry, and I have my custom shape from Google Earth rendered on the map. Now, at the minute, this doesn't really look like the finished article that I had to show you. And really, that's aesthetic. So I'm going to perhaps pick red for the internal, but I'd wash that out completely. So we have this shape on the map. The border can stay red, that's fine. Now, the only difference between what's in my view now and the finished article is the difference in the base map. So you remember, as we did before, we go up to the map option in the menu ribbon, down to map layers, and we'll go from light to streets. Okay, now that is looking pretty close to the challenge that I set. So you can see that that area sketches out kind of roughly. You can see I wasn't too sort of precise about the edges, but I've sketched out the outline of Greenwich Park and Blackheath. So I have a custom KML shape sitting on top of a default Tableau base map layer. Again, if you're still with me and you got this at home, well done. We're going to move on and look at some geojson data this time. And again, I'm going to show you, hit the plus icon to add some new data, drop down to adding a spatial file. And again, in your data sources file from the download, we have this geojson file called Eckert1v Eckert4.geojson. Now, geojson is based on the JSON format. It also stores spatially enabled data, and we're able to read this in. You're going to interrogate the geometry field and see that still we're dealing with polygon areas. So we've got another little challenge for you. You're going to try and create this base map using that geojson file. Now, again, don't worry too much about the color match. The key thing is I'd like you to have only this base map in the view. So hit pause if you want to make this at home, and then join me in a couple of minutes when you've got yours done. Okay, hope you had a go at that. We're going to go for the solution now, and we're going to begin again with adding the data in. So we connect data, add new data source, scroll down to spatial file, and we want this Eckert4 geojson. And then we're going to open that and have a little look at the fields. So you can see here again, as I said, we've got a geometry column. It's natively spatial. We have polygons as the spatial object type, So we're looking for this map to render areas. We'll go into our worksheet and then double click the geometry field to bring that into the view. Brilliant. Now, this was the key thing. So you'll see here that something special has happened in Tableau. The geojson file doesn't sit exactly over the top of the base map. And in the challenge that I set, I wanted only the new base map, not the Tableau default. So to do that, we go up to the map menu in the top menu ribbon, hit map layers. And then instead of changing the background map style, we just want to wash it out completely. So we're going to grab the slider and drag it across to 100% so that we're left with only our new base map. And the final thing to add was just a little bit of the aesthetic, the color detail. I just went for a sort of very light gray, white outline, white fill. And then the outline, I've gone for this kind of burgundy again. You can tell it's probably my favorite color. And there we have custom base map. If you got that far, again, well done to you. And to look back on what's actually happening in Tableau, what's going on here is that we have two different map projections in operation, one being the Tableau default and the other being the system that the geojson is encoded with. Now, I've sourced this particular geojson file with its particular projection from a great little web-based tool called Dirty Reprojectors that was produced by the super cool team over at Development Seed. Now, the link to that tool is in the description, and we'll be using it again in a later episode when we come to talking about hacking our way out of Tableau's default settings. We've done great work so far, and you'll remember that at the beginning of this episode, I said that we'll be using both Tableau and Alteryx for spatial data. So to close out this episode, we're going to look at connecting to spatial data in Alteryx. If you're following along at home, go ahead and open the starter flow in the participant material folder, and it's flow number 1 called adding spatial data. And I'm going to drop into my Alteryx canvas where I have that adding spatial data workflow already open and ready to go. Remember, you can pause if you need a second to find any of these files. I'll be here waiting when you get back. And before we do anything with this file, we'll have a quick look at the Alteryx canvas. Some of you may not be familiar with it. We've got a canvas area here in the center where we can drag tools into. We've got a configuration section for our workflow. The tools that we drag in to the canvas, they are dragged in from this tool ribbon across the top, where the many, many tools available in Alteryx have been grouped into sort of common functions. Ways of reading data into Alteryx and outputting it in the in-out section. Kind of data prep tools, all collected into this blue preparation tool palette. If we look at documentation, for example, very important to document our workflows. We can drag in a comment tool and make little comments, document our workflows as we go along, so we're able to share them effectively. But quite a lot of the tools that we're going to use in this session and later sessions, they're from the spatial tool palette. So we're going to give that a click. Now, in this tool palette, we have a range of tools that are useful for answering questions like, where are my objects? How do I get objects onto a map? Dealing with spatial aggregation, dealing with proximity analysis. So you have buffer tools, nearest tools, distance tools. Quite a lot of sophisticated spatial analysis we can perform with quite a limited number of tools. And you'll also notice that some of these tools have a little gold star beside them. And that is because Alteryx has picked up that I use them a lot, or I've chosen to make them favorites so they'll come up in my sort of quick access menu. So if you see I hover over one of these tools, I have the option to click the star. And when I do that, that becomes available in this favorites palette. And that's sort of my quick access. So you can see all these tools that I use quite often. And the tool that I just favorited is the smooth tool, and that's in there too. I can get rid of it by unclicking that star. Now, in terms of what we want to do in Alteryx today, really, we want to replicate what we've just done in Tableau. Already, we have our spatially ready school location data. And if we just click this, you can get a sense immediately with the preview pane of what fields are in here. If you want to get a closer look at this, you can drop a browse tool in. And let me just reset that location, which isn't picking up where my file is just now. So let's redo that. Perfect. And I'm going to run this. And the browse tool will enable me to see that data in this output window. Again, you can see rich data set. If I scroll across, you can see postcodes. You can see X and Y. You can see a range of different sort of address details, but nothing other than numbers and text. We don't have a spatial object here. And I can prove that we don't. Not trying to fool anyone. If we click this metadata button, this is going to give us a look at all the fields that we have and also the type of data that we have available. So you can see the XY, they're currently in as V strings. So this is spatially ready, not spatially enabled. If we want to perhaps go back one step and add spatially ready data from scratch, we can do that. I'm going to leave the school locations in. I'm going to drag another input tool from my favorites. If that's not in your favorites yet, just go to the in out menu ribbon and drag in the input data tool. It's going to ask us to connect to a file or a database. And this time I'm going to connect to our traffic locations, CSV. Again, that's spatially ready, but not spatially enabled. So I'm going to go to Files. I'm going to select my file, and that's in the Data Sources folder of your download link. And we are looking for the traffic counts file. Let's bring that in. Here we go. Stick another browse tool in here so we can take a look at what's coming in. And we'll hit metadata. Sorry, we'll hit data rather than metadata. You can see again, we have explicitly named latitude and longitude fields, but they're just, well, at the moment, let's see, they are just V strings. They're not actually numbers, but they're definitely not any spatial data type. Now, in terms of adding the spatially enabled data, it's really the same process. So I'm just going to select all of these and just delete that for a second. In the same way that we'd connect data in Tableau, I'm just going to drag another input tool in and just connect to a different file type from Alteryx. If I perhaps go to my shapefile this time, and I'll go to my London shapes in my data sources, and I'll go to London boroughs. Now notice here that you have the option, or Alteryx is picking up the options of the different file extensions that you can read in. It's not picking up all of them, but it is giving you the option of the .dbf, the .shp, and also an XML document. But again, the one that we actually want to bring in is the one that is called .shp by name, but also the one that is SHP by file type. So we can select that and hit open. And we're going to bring that in. And again, let's stick a browse tool on the end. You can see immediately from the metadata, no XY, a spatial object. And let's look at the data and hit the run. Magical. So our spatial object we have generated, it is a polygon. And at this stage, you can see that visualizing geographic data in Alteryx is not fantastic, but if we drag out this configuration window for the browse results, we'll get the ability just to feed in a base map underneath this polygon data to give us a little bit of context. So for those of you who know the general shape of London, this probably looks about right, but we probably need the context. So I'm going to put in the Alteryx street layer. And there we go, that's popping in. And that looks good to me. That is the extent of London sitting there within the M25. All right, so that's one type of shapefile, a polygon coming in here. I'm going to add in our polyline just for completeness. So I'm going to go for input data. Again, you won't have access to this polyline file, but don't worry about that. You can just watch for now. I'll go for files, again, select file, and I'm looking for my roads. And from all of these, I want my TV road link.shp, the SHP file. I'll open that. Same procedure. I'm going to drag a browse tool from the in out menu ribbon from that palette, drop it in. I'll hit run. And let's have a look at the browse tool here. To do things in the same order that we've done before, if we scroll all the way across, we're looking for a spatial object. Again, we've got lines. That's what we expected for roads. You can see that these are plotted in this Alteryx configuration window for the browse tool. Again, no base map being put in, but we can choose to put in a base map. Maybe I want to put in satellite this time. Is that going to work as a view? Yeah, not too bad, not too bad. It's okay for context. So we're doing well. And this KML, again, that's the same procedure. Going to get rid of these. Quickly add in my KML just to show you that we're not dealing with anything special here. It's just connecting to a file type, running it in, and see what we've got. So go to Files. I'm going to select our file. And then we're looking for our spatial essentials data sources. And this time, there we go. There's the Google Earth icon. We're going to add in the KML and open that up. Pop a browse tool into the canvas. I'm going to run this flow. There you can see a polygon, magical. This is exactly what we had in Tableau. Just expand this configuration window a little and we'll get some context. Yeah, maybe we'll go satellite again so we can see this is Greenwich and Blackheath. If we zoom out a little, you can see the Thames starting to pull in. And if you're fans of EastEnders, that's going to be a familiar view. So you can see there my rough around the edges outline of Greenwich Park and Blackheath brought into Alteryx by KML. That is spatially enabled. It's got a polygon as its spatial object type. Now, today we're not going to read the geojson into Alteryx. That process is actually a little complex. We will leave that for now anyway, but we will come back to it at a later stage. Last up, let me get rid of this KML because we're going to move back to look again at our spatially ready schools location data. And we're going to finish with looking at how we spatially enable these data using Alteryx. Well, what we want to do, if we drop, actually, let's do that here. If we take a look, we have these X and Y fields. And to go from spatially ready to spatially enabled, we need to add that spatial object. And that spatial object is going to be a precise point in this case. That is going to be generated by collecting the X and Y fields together into a single geometry to make or create a point. Now, phrasing things in that way helps me to understand that the tool that I need to do this in Alteryx is found up here in the spatial tool palette across the top, and it is conveniently called Create Points. So I'm going to pop that into the view, and let's expand this configuration window a little so you can see what's going on. In the configuration, to create points from our latitude, longitude fields, in this case, they are called X and Y. We've just got to select them properly. Our X field is called X. Our Y field, our latitude field, is called Y. And all we're going to do is pop a browse tool in at the end and see how things change with the simple addition of this create points tool. So let's run that. All right, first thing, in our browse tool, we are generating a map this time. And we weren't able to do that before because we didn't have any spatially enabled data. If we look at what has happened to the schools data, you can see that we've had the addition of a new column, and that is a spatial geometry. And the geometry type is point. That's the object that we want to draw. If we refer to the map, it is rendering each of those school locations as points. Again, if we pull that out a little bit by just holding down left click and dragging that, and we'll use the drop down here to select a base map. Again, maybe let's go streets here. And we've got that context. So we've got that full range of schools data, spatially enabled. So going from just numerical values representing latitude and longitude to a collected geometry representing those points in space. And we've put them on a map using the Create Points tool in Alteryx. Now at this point, we are at a natural break in our Spatial Essentials context. If you come back and join me next time, we're going to take a look at how we deal with X and Y data that isn't latitude and longitude, and also how we deal with UK postcode data. But until next time, keep exploring and feel free to reach out to us here at the Information Lab for solutions to your data challenges. To stay up to date with all our YouTube content, hit the bell icon to subscribe to the channel. Stay safe, and I'll see you all next time.